So students had a couple questions out of the 6-4 math connections. So let's take a look and see what we've got. We've got question 2, 3. I'll start with those, I guess. 2 and 3. A 10-inch circular pizza costs $4. To find the price X of a 14-inch circular pizza, is it correct to set up the proportion? The proportion seems correct. The issue is that it's a circle. And a circle is not a straight line. So if you had a straight line, for example, maybe you were cutting ribbon or streamers or something like that, and you had a certain length, if 10 inches straight line cost $4, then you could figure out how much would it cost for 14 inches, right? You could figure that out using this proportion that's here. But is it correct to set up this proportion? The answer is unfortunately no. It is not correct. Okay. They have it matching. The $4 matches up with the 10. The X matches up with the 14. So all of that seems good. The issue is not really. I don't know how else to say this. I did show this in class today, and some of you said, "Do I need to know that?" The point is that when you have a circle, what you're measuring is typically not a straight line. You're measuring the area, or at least the surface area that is circular. So if you're talking about a pizza, usually you want to measure it by kind of how many square inches. So right here, when they're measuring inches, inches doesn't do much. Inches would be like the distance all the way across here. And that's 10 inches, which is great. But the amount of area that comes from a pizza is pi r squared, or the area that comes from a circle, I should say. And so what you'd have to put is the radius, and the radius would be just 5. So this would be 25 pi would be my area. That is what I would plug in over here where they have 10. I would not put 10. I would have to put 25 pi. Okay. And that way, what you're basically selling people is the amount of kind of square inches of pizza that they order. If you made little tiny squares that were 1 inch by 1 inch, you could say, this is how much a pizza costs for this much. And so that's the idea. So for that one, they're not on the right track. They have parts of it set up correctly, so I'd probably commend them on that, but that's definitely not the whole thing. Okay, math connection 3. It says prove these pieces. Okay, well, let's see here. I need to prove if A over B equals C over D. Well, I'll tell you what, I'll pick one of them. I don't mind doing that. I certainly don't mind doing that. Which one do you want to try? Which one? B? Okay. Now B, I'm going to use the fact that A is true, but here's kind of the way that I would go about doing it. Let's get a little white space in here. I mean, we could do other ones as well, I guess, but because really part A, maybe I should do part A, because part A is the one that is kind of the linchpin here. If you can do part A, then all the rest of them come along for the ride. Let's take a look. Okay, so I'll do A. Now remember, what do I know? I know my if statement. If A over B equals C over D. Okay, so if A over B equals C over D, that means these two things are equal. And if they are equal, then A over B plus 1 is going to equal C over D plus 1. Why is that? Because of the addition property of equality. I can add the same value to both sides, and it doesn't change the fact that they're equal. Okay. So now I'm going to try to add these together, but they're fractions. And if they're fractions and I tried to get them added, I need a common denominator. So A over B plus B over B has to be equal to C over D plus D over D. And again, if you need it, remember B over B is 1. D over D, it's just a fancy way of saying it. I'm drawing a really big kind of 1 around it so it kind of sticks in your mind. Just adding 1. And then you can just simplify. So now they have the same denominator, and I can just add the numerators. So A plus B must equal C plus D over D. So notice I started over here. I worked my way over, giving a reason for each step. And my final result is here. Perfect. Okay, so if I was going to B, I would say, I know this is true. And then anytime these two things are true, what can I do? I could rewrite them. I could take the reciprocal of both sides. And the reciprocal of both sides allows me to rewrite it as B over A plus B is equal to D over C plus D. So there's another thing. So if they give you one of these and says, hey, is B over A plus B equal D over C plus D? You could say, heck yes, it is, because I took something that's true and all I did is flip it over. Okay. All right. Let's see here. What else could we show? So if we had to prove B, where it was actually A over A plus B, not B over A plus B. Okay, well, off we go. We need to show that A over A plus B is equal to C over C plus D. So this is a piece that when you're doing proofs, you kind of want to be thinking of kind of not just where am I at right now, but where am I trying to go? The good thing about proofs is they always have to tell you where you're going. So if I was doing B and I would say, I want to get down over here, I want to be able to say, so A over A plus B is equal to C over C plus D. I want to be able to say that. Now, right before that, I must have had something that looked like this because I just flipped it over, right? A plus B over A must be equal to C plus D over C. Okay, that seems reasonable. All right, and then here, notice I have, because they're ordered together, I could kind of rewrite them. So I got kind of little arrows that kind of guide me on my journey. So I'm working my way backwards using only true statements. And I definitely want to start with something I know is true. So let's see if I can get to where, because sometimes it's hard to figure out what's my first step. So what I'm doing is I'm kind of working backwards. And that was one of the tips we learned in chapter 1. So this would be A over A plus B over A has to equal C over C plus D over C. So there we go. And so A over A plus B over A, and A over A is 1. So 1 plus B over A has to equal 1 plus D over C. That looks good. And I'm going to bring it back up like I was back over here the whole time. And so that means basically this is what I have to show is true. And is it true that B over A is equal to D over C? And what did I start with? So let's go back to my starting point now. If A over B equals C over D. Okay, if A over B equals C over D. Oh, then I can flip both sides because that is proportional reasoning, and B over A is equal to D over C. Got it. From there, I add 1 to both sides, and now it looks like I've got a path that takes me all the way down to the end, which is the statement I'm trying to prove. So if you get stuck on any of these, you can start from the beginning and work your way down, and you can start at the back and work your way towards the middle. You just have to make sure you meet in the middle with some true statement. And that's the idea behind those. All right. Woohoo! There we go. Let's see here. What else? Yeah, I think I did kind of pushed on 2. I'll leave 2. Clear my drawings. And let's see, what else do we have here? Number 7 and number 12. Okay, let's take a look. Number 7 says, in a condo complex, 2/3 of the men were married to 3/4 of the women. Yep. And I gave a hint, MLO video, said, hey, remember, you have to have a certain number of men, and that same number of men has to be married to 3/4 of the women. So if you're looking to compare how many are married, you have to have the same number. So 2/3 of the men. Okay. So how many men were married? I don't know, but I know it's 2 out of every 3 men. So could there have been 2 men that were married? Yes, it's possible because that's 2. Maybe there were 3 total men in this condo complex. So it could be 2, it could be 4, it could be 6, but obviously then it has to be some multiple of 2. Now look at the women. The number of women who were married is some multiple of 3 because it says 3/4 of the women were married to these men. So again, 3/4, it could be 6 out of 8. There could be 8 women total and 6 are married. It could be 9 out of 12. But notice I'm making a little sequence there of 3, 6, 9, all those different pieces. So then as you look at it, the number of people that have to be married to each other then, right, um, is that multiple. So those have to match up. And there you go. So the number of men has to be equal, the number of married men has to be equal to the number of married women. And what is the ratio of people to the total population? So again, once you know the total of men and the total of women, you can go through and say, well, those have to be equal. You might be able to find a multiple of those and then be able to kind of compare, well, what would that look like in terms of the total number of people? Because let's just say there were 3 total men and 4 total women, that would be 7 total people. And so that's when it says the total adult population will be whatever you find, and you take those and your denominators have to match up. So there's a little hint there, a little nudge. I do not want to give that one away because that is a good problem. And whenever you have a good problem, there's nothing better than actually solving it. So um, I'm not going to be able to give you too much on that one. But if you wanted to, you could also find and solve this one with variables. So if you wanted to practice a little bit of your algebra, maybe, let me jump up here. And so if you don't know how many men there are, it doesn't really matter because like in algebra, when we say 2/3 of the men, we could just say 2/3 of the men. And how many men are there? I have no idea, but I'm going to call it M, a number of men. And that would mean like over here, 3/4 of the women. Okay, well, 3/4 of the women, right, are married. And that has to equal 2/3 of the men. So I have a nice little equation there. And it says, what is the ratio of people in opposite sex marriages? Total people would be the married women plus married men. And the total population would be men plus women. Now, what's great is if you do a little bit of algebraic work here, you might be able to solve for one of these variables, like maybe solve for W. And if you solve for W, then you can substitute that back in for W. And you've got a beautiful equation that just has one variable. And if you choose to do the algebraic approach, again, that's the second part here, which is I explain how to do this without knowing the actual number. Then you could factor an M out of the numerator and denominator. And once you do, your M's are going to cancel. So that's the idea for this problem. Again, not trying to do every bit of it here because I'm trying to give you a little nudge and say, hey, I want you to try this one. That's why I picked that problem. Okay. Let's take a look. And the last one is Math Connection 12. Is this the one with the Statue of Liberty? I think it is. Yep. Statue of Liberty read the arm of the Statue of Liberty is 42 feet long. She would like to know how long the Statue of Liberty's nose is. Okay. Well, since we're in a section on proportional reasoning, there's almost a nudge here to kind of say, I wonder what we could do with proportions. Sounds like Mandy figures out this arm of the Statue of Liberty is 42 feet long. So maybe you could use Mandy in this case. Like how long is Mandy's arm? And maybe compare Mandy to the Statue of Liberty and say that, hey, Mandy's going to be proportionate to the Statue of Liberty. So Mandy's arm to the Statue of Liberty's arm should be in proportion. And then Mandy's nose to the Statue of Liberty's nose. That would be a reasonable way to do it, where maybe Mandy feels like she's actually part of it then. So again, then you'd measure the length of the nose. You'd have a ruler. How far out does Mandy's nose stick? And then how long, say from the tip of the shoulder down to the fingertips, how long is Mandy's arm? And you could actually come up with a connection. So all of a sudden you've got Mandy figuring out and estimating how far that is. And then if you wanted to, you could even go then Google it afterwards, now that Mandy has an idea of something, and you could use that to check. Okay. Other approaches, sure. I mean, if you're going to go out and Google what are the proportions, like what is the scale factor for the Statue of Liberty? I mean, there's nothing wrong with that. But again, the scale factor really wouldn't help you know how long her nose is, right? It would just say this much to this much. So that's your scale of proportionality. And there's nothing wrong with that. But again, you'd then need to know how how big the model of the Statue of Liberty was, how big was the nose on the model, as you go forward. And unfortunately, that is something you'd kind of have to Google to figure that out. So if you're trying to avoid just jumping to Google to try to find the answer, that would be what I recommend. Okay. So there are the 4 from that section. Hopefully that helps. That's it for now. Off you go.